Welcome back to Sipas Spimmer Garage. Many of you are probably familiar with the Speeduino and also familiar with these Speeduino plug-and-play boards that I have designed for different BMW engines. Like this one, this is for M52 and this is actually pretty old model, but we will get back to that later. Anyways, the regular Speeduino boards, they use this good old Arduino Mega processor card, the one that is here. And also many of my designs also use this processor card. And this is all fine. This is quite reliable and everything cheap to buy and so on. But of course there's limitations with this. The processor itself, it's quite old and it's lacking the features that nowadays different processors have. Speeduino now supports different kind of newer processors that have newer features like CAN bus and SD card locking and so on. But of course none of that work with these Arduino Mega boards. And currently if you want to use those newer processors like TNC and STM32, you need to buy completely different Speeduino ECU. You cannot just replace this with the new one. So yeah, if you ask me, it has been a little bit problematic with the Speeduino that there's no upgrade path from this. You need to buy whole new ECU if you want to use the different processor with the new features. You cannot just replace the processor card and leave the rest of the just perfectly working ECU intact. To help out with this issue, we have this video's sponsor, Speeduino. I just got a package from them, so let's check what we have here. So yeah, this is what PCBWay sent us. These are boards designed by me. These are STM32 based processor boards meant to replace this Arduino Mega that is usually used with Speeduino boards. Let's take one out of these packs so I can show better. Here you can see quite well how this will replace the Arduino Mega boards. So these board dimensions, these are identical to Arduino Mega. Then this pin header, this is also identical, so it will slot in directly where this Arduino Mega is. The USB port is also in the same location, but then we come to the differences. So for example, here when Arduino Mega has this DC connector that is not used with the Speeduino, here I have connector for CAN bus. Then next to that we have SD card slot. So this will also support SD card locking that is already in the Speeduino firmware. Then here we have the boot and reset buttons. Then we have these dip switches here. So there's two modes that you can connect this to the PC. So there's this single USB connector, and you can set these dip switches so that the USB connector will directly connect to the STM32 chip and it will emulate the serial bus, which is the fastest mode because it's not limited by the serial speed. Then is there another mode that there's this FTDI chip here. So you can use the dip switches to check that one. And the PC will then connect to the FTDI chip, and then there is serial bus to the STM32 chip to communicate with. And that's basically the same mode as the Arduino Mega uses. So here's this chip that will connect to the PC, and then there's serial bus to the processor itself. The benefit from that is that with this FTDI chip, there's a serial that you can connect to the Bluetooth. So if you want to use the Bluetooth connection to lock stuff or maybe tune this, then you need to use the FTDI mode. But yeah, the problem in that is that then you are limited by the serial speed. So with the native USB, you can transfer data much faster here. Then there's this slot for the battery. So this STM32 chip, it has the real-time clock built in. So when you install the battery here, it will keep up the time. And you will then have the date and time on the SD card logs when those are taken, so it's much easier to see what's going on there. Then of course there's a lot of these extra components that are not in the Arduino Mega board, and that's mainly because the Arduino Mega is 5-volt processor and this STM32, this is 3.3 volts, so it doesn't directly work with the Speeduino. So these chips here, these will convert some of the outputs from 3.3 volts to 5 volts on the outputs that matter. And then these ones, these will convert the 5 volt analog signal to 3.3 volt analog signal here. So yeah, these are basically all conversion chips from 5 volts to 3.3 volts. Then of course we have a couple of crystals. There's the main 8 MHz one and there's 32 point something kilohertz one for the real-time clock. Then we have the CAN bus chip here, so this is the transceiver, so you can directly connect the CAN bus wires here. And lastly, we have the flash chip to store the tunes. In these STM32 chips, in the Speeduino, we have 3 ways to store the tune. First one is to use the internal flash on the chip here. Then there's this external flash option. And the last option is to use the SRAM that uses the battery to keep the tuner in the memory. But I'm not recommending that one to use. And these boards, these have been made by PCBWay, and they have also populated and installed all these components here. I did leave out these USB connector and CAN bus connector and these pin headers, because those would have increased the price, and I can easily just solder on these. But the rest of these are really tiny surface mount components, so I highly recommend getting these done by some manufacturer like PCBWay. But yeah, because this is sponsored video, they wanted me to show the manufacturing quality of these boards and the assembly. So let's take a closer look of this board, and after that let's solder on the missing components and try this out on the Speeduino board. This is now one of those PCBWay boards under the microscope, and let's adjust the polarization a little bit to make this look nicer, or maybe make out some of the differences. I think it's best like that. At least the silk screen, it looks really nice. There's nothing really wrong in that. The text is all crisp and so on. All the traces look really good. All the soldering looks pretty much perfect. Wait a minute, I think that crystal is even see-through. Let's zoom in. Cool, you can even see that fork there. Let me focus this more, like that. Yeah, you can even see the tuning fork in that crystal there, so that's pretty cool. I must remind that this is really tiny component and we can still see inside like that. Let's zoom out and check rest of the board and maybe see how the soldering looks here. So let's move here and maybe check out the solder closer on that. Maybe let's say that SPF flash there. Yeah, there's some flux residue there, but that's fine. But even that looks perfect. And yeah, if you look closely, those solder points there, those are absolutely perfect. So the soldering process also seems to be really good. Oh, there's the LED. You can even see the wires inside the LED and the chip. Oh, what was that? Yeah. Maybe let's check the processor part, because those are the maybe most difficult ones to solder, at least when I soldered those by the hand. Okay, these are the processor pins. Everything looks perfect here, no complaining. Let's check out the other side. Yeah, this is also perfect. Even the solder max alignment seems perfect. Let's check the corner of the board if it's still good there. Yeah, the alignment of the solder max seems perfect here too, so there's no offset between the sides of the board. Maybe let's compare this to the board from the competitor and see if the solder mask alignment is same there. I must remind that this board from the competitor, I have soldered it myself, so you cannot really compare the solder quality, only the board quality. This is the competitor's board. Let's zoom in. Oh, you can see that the solder mask, there's a lot more room around the pins here than compared to the PCBWay boards. Let's see the pins from the processor. Yeah, this is much worse. The solder mask is not even close to the pins like in the PCBWay board, and there's a lot of offset there. Well, there's some offset in this solder mask here, so yeah, it seems like the PCBWay board has much better quality than the competitor board that I have. Yeah, there seems to be some pubic hair there, but yeah, I think we saw enough. Maybe end here and move on. Oh dear, I thought that I have a lot more of these USB connectors, but I did only find one. But well, that's enough to test one of these, so let's put this on. Then the connector for the CAN bus. And lastly, these pin headers. I think you can get the correct length ones, but I have these long ones and I will just cut these to length. Let's clean up a little bit of the flux. These are just Q-tips and acetone. Yeah, I think that's enough. If you ask me, this looks really good, but I don't know if I'm allowed to say that from my own thing. Of course, the quality from the PCB is also really nice. But yeah, it's now fully done. So to be able to set this up on the PC, you need to set the dip switches. So I leave the USB on and put the FTDI off. So it will now use the native USB. Then we have this power. So this means that when this is on, this can be powered through this USB. And it's easy to set up everything on the PC. But if you want to make this act like maybe, let's say, normal ECU, you can put this to the off position. And then you will only have the power for this board through the Speeduino. So only when you power on the car, then you can have the processor running. So that would be usually what you want to run in the car. But now to set up those on the table, I will set this to the on position. And this last one doesn't do anything, so that can be left as is. Now we can connect this to the PC. So I'll plug in USB here, and then I will hold down the boot 0 button. Then plug in the USB to the PC. It should detect that now. I have all the files you need on my GitHub page. This one here. And from these we need these binary files here, Speeduino binary files. These are per version here. This is the newest one. There is a couple of different versions, so there's different versions if you want to use the internal flash or the SPI flash. I will recommend using the internal flash, but SPI is also available. And also there's these ones that use the USB, and there's these ones that you will use the FTDI chip if you want to use the Bluetooth and so on. And there's these versions that use the fast ADC. So that means that all the analog sampler rates are much faster in these ones. But anyways, we need to use the STM32 downloader for that, or I mean STM32 programmer, this one here. Let's open it. Here I will select the USB. If you will use the FTDI, then you need to select the UART, but in this case we will use the USB. We update this. It has now found the board, so I will connect. Like that. It shows FFFF here, so it's totally empty chip. It also shows the device and everything here. Then we can go here and we will select the binary file. I have cloned this GitHub repo to my PC, so we can go here, documents. Here we have the binary files. Let's select the newest firmware, and I will take the regular. So this is probably what most of you want to use. So I will select this one, open, and start programming. Okay, that should be it. We can disconnect like that, reset the board, and if we go to the device manager here, we should see COM port here, USB serial device COM7. So it is now up and running. Let's go to the Tuner Studio. Let's make a new project. And I think we can detect here. It should find it just like regular Mega board, like that. That's the firmware version that we did upload. Accept. Yes, we will let it download the ini file. Next. Oh, I already had that. Next. And of course Celsius. Yeah, we will use bar. We don't have the... Okay, this is something you need to change. So you need to change from Arduino Mega to STM32 on this point to have all the features working as they should. IFR, we want to have the hardware test. Yeah. Then next. It's all good. Then next. Finish. Of course, now this is basically same as empty Mega, so we need to do the sensor calibrations and all like you normally will do with the Speeduino. So for example, let's load the Tune Forest. I should have something here. Okay, let's reset it. Okay, the temperature sensor should be okay now. Then at the AFR sensor, this one I have the PLX, so write that in. And now we should be able to plug this into the ECU. So disconnect this. Here's the ECU, so let's take the Mega board out, put this one in, like this, and plug this in. Okay, the map sensor is working. We have the 100 kPa temp sensors are also okay. These are showing minus something, so that's my calibration file. And we can do the hardware testing, for example. So at least the injector output should be working. So, I mean ignition outputs. So that one on, that one on, that one on. That's fine. Yeah, like that. I think we can also test the injector outputs quickly like this. So I will put the 5 volts to the 12 volts like that. So yeah, all the outputs are working. So I think we can now try this on the car. And of course I need to remind that this has the old board that has the patch fire injectors and then the wasted spark. But the newer boards, they have both sequential injection and ignition. But with this Arduino Mega board, you can only do the sequential injection and not the ignition. Or well, you can do one sequential and another one will be not. But with this board, you can do the both injection and ignition sequentially, all up to V8 engines. But of course, this is for 6 hill. But yeah, let's try this in the car. Okay, that's in. You can ignore the mess. Let's plug that in on the PC. Not. And it now goes on, but there's also the dip switch that you can select that the PC doesn't give any power. So in that case, if you disable that, then this will only power up when the car has powered up. But that's up to you to decide what to use. But yeah, I think that should run like that. This Tune is not like perfect for this car, but I think it should run just fine. So let's try. Yeah, it runs fine. Let's try. So yeah, that was just a random tune I have for these engines, but as you can see, it works like that, and yeah. But I think that was pretty much it. If you have any questions, you can ask in the comments, and I will answer there. Well, maybe a few more words before we end this video. First of all, I wouldn't recommend these for the beginners, even though as you can see this works quite nicely and there's nothing really special you need to do. But if there's problems, those can be pretty hard to debug. So for that reason, I wouldn't recommend for these beginners, but of course you can do as you want. I would more recommend these for the advanced users that can maybe do their own coding and use the more better feature set that this processor has, use the processing power and so on, and maybe make some pull request for Speeduino firmware to use these kind of features that the STM32 and the TNC has. But of course, if you just want to have the CAN bus or the SD card locking and that kind of things in normal Speeduino, you can use this just fine. Then you are probably asking how to get one of these. Well, I was planning to get a bunch of these and sell these, but well, I don't really have time to do that, at least at the moment, so you probably need to get these done by yourself. Luckily the PCBWay site, it was really easy to use to get these done and fully assembled, so I will put on the GitHub all the files I did use to get these done at the PCBWay, so you can probably get these from there if you want. But yeah, if you have some questions, just comment below and I will answer there, and I will put the links to the GitHub and that kind of things on the description so you can check out those.